All right, we are back. We want to look at sampling procedures or sampling techniques, and we want to see what these are. So sampling procedures or sampling techniques. We can actually also call them sampling designs, right? What are the different plans or methods of sampling that are there? Okay. Now, basically, it's basically a technique chosen to pick samples from a given population. A plan. It is a plan. There are different kinds of plans. All right, and there are two. They are divided into two: probability sampling and non-probability sampling. Probability sampling and non-probability sampling. These are the two kinds of sampling procedures or sampling techniques or sampling designs that you can use: probability and non-probability sampling. Now, what is probability sampling? Probability sampling is where everyone in the population has an equal chance of being selected. Everyone has an equal chance of being selected. And this scheme is one in which every unit in the population has a chance greater than 0 of being selected in the sample. All right. Just a minute. So basically, we are just saying, just trying to look at something here. We and trying to multitask. There are some things that are needed from my side. But anyway, let's continue. Probability sampling is basically that it's a procedure, sampling procedure or a sampling technique where every unit or every member of that population has a chance of being selected, but that chance is based on probability. In other words, everyone has at least a chance of getting selected. So for instance, if you are dealing with, if you are trying to pick samples from the ICT department group, you want to pick samples of students and staff. Everyone has a chance of being selected. There is no particular area of interest in that particular group. Everyone has a chance of being selected, but only some are going to be selected as a matter of fate. Okay, as a matter of fate. So I can just pick go, and that's why it's normally called a random sampling. Random. Out of 100, I will pick 20 or 15 randomly. All right, randomly. So probability is where everyone has a chance of being selected. Anyone in the population unit can be selected, but the ones who should be selected will be out of fate or out of chance. Okay. There are 4 basic types of sampling procedures, probability sampling procedures. There is simple random, right? I think let me list them so that you can actually see them well. Simple random, systematic sampling, stratified, and cluster sampling. So I think when listing that way, it looks better. So let's begin with simple random sampling procedure. Simple random sampling procedure. Now, simple random it provides the base from which other more complex sampling methodologies are derived. Basically, for you to collect, to do a simple random sampling, you basically first prepare an exhaustive sampling frame. You prepare a source list. So if it is a students of Tech University, you prepare a source list that is made up of, that groups all those students according to, you can choose departments, age, or whichever criteria you want to choose them. I've just chosen department because it's simpler, right? So you create an exhaustive sampling source list, or what we call a sampling frame. Then from this list, the sample is drawn so that each person or item has an equal chance of being drawn during each selection round. What you are basically saying that, for instance, let me just write here so that you can understand. For instance, from ZTech University, ZTech University is the sampling unit, right? Created a source list, created a source list of students and staff per department, right? An exhaustive source list. Exhaustive means it contains all the members, okay? Staff per department. Then begin to choose randomly from each department in rounds. What is a round? A round is one particular basically it's a cycle. It's one particular cycle of collecting a sample. So if I have, e.g., from 10 if I have six departments, if I have 6 departments, all right, and each has, you know, I've grouped every department according to the members of that department. I'm going to be picking the samples in rounds. So round one, I go per department, I pick one sample, right? I go ticking which sample. So you know I already have a source list. So I just tick a particular member, all right? A particular member. I just tick that. Ticking it means that I will pick that particular student or that particular member of that department. I go to another department, I pick one. Just randomly, everybody has a chance, okay? So it doesn't have to be number 2 or number 3 or number 4. I just do randomly, okay? I tick one. I go to the other department, I tick another. I go to the other department, I tick another. And then I'm done with the 6 departments. I've ticked one per department. I go again, another round. I pick another randomly. I pick another randomly. I go to other randomly. I finish. I've now picked 2 from each department. Those are 2 rounds. I go another round. I pick another. I pick another. I pick another from another department. Those are rounds. So that is called simple random sampling, simple random probability sampling. Simple random probability sampling. What you do, basically have an exhaustive sample list. Then from that sample list, go picking randomly one per category, if it's department or age or year of admission, whatever. It depends on the source list, okay? So from per category, you pick one. You go to round two, you pick another. You finish. Round 3, you pick one from each. You finish. Round 4, you pick another, all right? Then when you realize you have picked enough samples for each category, then you can stop picking or choosing. You can stop randomly choosing your samples. All right, that is called a what? Simple random. All right, then there is what? Systematic random sampling. Now random is where you picked randomly. You were never trying to do, you are not trying to choose. You are just picking randomly, okay? Just tick from the source list. But systematic is often used in place of simple random sampling. And in systematic sampling, the researcher selects every nth number after randomly selecting the first through nth element as the starting point. For example, if the researcher decides to sample 20 respondents from a sample of 100, no, from a population, not from a sample, from a population of 100, every 5th member of the population will systematically be selected. Now, this is what happens in systematic sampling. You remember, for random sampling, you just went per round picking a person, all right? Picking a person or, picking a person or a member of that population, just randomly. You don't determine the number in which they lie, just randomly. Now, in systematic is where you're going to pick a number. You will say, I'm going to go per round, just like random, simple random. But per round, the first round, I'm going to pick the second person in the list. So round one, I pick number 2 from ICT department. Round one, number 2 from business. Round one, number 2 from engineering. Round one, number 2 from hospitality. You finish the 6 departments. Then you say round 2, I'm going to pick the 5th member from each category, the 5th. So you pick round 2, number 5 from ICT. Round 2, number 5 from engineering. Round 2, number 5 from hospitality. Round 2, number 5 from media department. So that is systematic, where you use the nth number, okay, up to an nth number. So you can use from number 2 to number 7. So you say round 1, I'm going to pick number 2 from every category. Round 2, I'm going to pick number 5 from every category. Round 3, I'm going to pick number 6, number 7 from every category. Round 3, I'm going to pick number 9. Round 4, number 9 from every category. Basically, you have used the numbering of the students. You've used the numbering of the students to get a systematic sample. But do you remember, it's still random? It is still random because everybody has a chance, okay? Still, everybody has what? Everybody has a chance. It is a probability sampling. Everybody has a chance. It's just that you've divided the chances into numbers, that the person who's going to qualify to get to become one of your samples is going to be part of a certain number, all right? So that is systematic. Then let's look at stratified. Stratified. Why is this becoming... Just a minute. All right, stratified sampling. Now, you know from the stratified from the word strata. A stratum is a level. A stratum is a level. I think when you did geography, you did the different levels of, you did the different levels of soil, or the different levels of the Earth's crust, or the different levels of the atmosphere. So you would say that one level, if it's ionosphere or thermosphere or whatever, it's a stratum. A stratum is basically a level, all right, a level. Now, stratified sampling is basically one of the most effective, and when a researcher wants to get a representative sample of a population. Now, basically, it involves categorizing the members of the population into mutually exclusive and collectively exhaustive. Now, do you hear what this is? Mutually exclusive and collectively exhaustive groups. Then an independent simple random sample is then drawn from each group. Now, let me just show you what this looks like. For instance, ZTech University, you've picked a source list. The ZTech University is a sampling unit, the geographical area. Then from ZTech University, you have had an exhaustive source list, all right, per department. Are we together? Then in that department, there are those students who belong to first year, who belong to second year, or belong to third year. So instead of just having, ICT department having all students, let's say 200 students, they are all mixed up. Yeah. Instead of doing that, and of course, the other departments also, instead of just having a number, arrange those numbers in a manner in which from number 1 to 5 is first year, or you can actually have a row, just a row, or something. You can generate a table and put them all in this category, in this source list, this particular category. From number 1 to 5, this is first years. Number 6 to 10, this is second years. Number 11 to 30, this is third years. That way, you go again to what? To the other department. You do that again. What you are doing, you are creating strata. All right? Levels. Okay, so now from those levels, you can now do a systematic or a random. All right, so you've divided them into levels, the different students into levels. Now you can do what? A systematic or a random. So now you just go each round. Each round you pick from first year, you pick one. You can do a random. You just pick one from first year. All right. From second year, from you are dealing with first years. So you go to the next department, round one still. First year, you pick one. Next department, round one, first year, you pick one. When you are done with the 6 departments, you go another round and you pick what? You go another round and you pick what? You pick for second year, you pick one. Second year, the next department, you pick one. Second year, the next department, you pick one until all the 6 departments you've picked for second year. All right. Or also, you can also do a systematic sampling, where you have those strata, those levels, first year, second year, third year for each department in the source list. But then you say, I'm going to pick number 2 from first year, from each department. All right. So you go to ICT department, unaangalia first year, una pick mwenye ako number 2 hapo. All right. Probably were arranged in alphabetical order, so you pick number 2 there. You go to first year for hospitality, you pick number 2 in that first year group. First year from media department, you pick number 2. So basically, you've chosen either random or systematic, but you have picked those samples from different strata or from different levels. Are we together? Now, basically, why are we saying it is the most effective? Because you get a good representation of the population. You have not only divided the population into departments, you've also divided the population into what? Into year of admission, all right? Year of admission, okay? Which is more reliable. There are things that first years experience or second years, that years for years experience or know about the university that first years do not, all right? Yeah, so basically that is it. It's the most effective because you get to group your source list even further into levels or strata levels. All right. Then what is cluster sampling? This is number 4. Cluster sampling. It's still a part of our what? Probability sampling. Now cluster, you remember cluster populations in geography. In cluster sampling, a cluster or a group of population elements which constitutes the sampling unit instead of a single element of the population. The sampling in this technique is mainly geographically driven. The sampling in this is mainly geographically driven. So for instance, or just let's finish up reading this and then now I can explain. The main reason for cluster sampling is cost efficiency, basically the economic feasibility. The sampling frame is also often readily available at cluster level and takes short time for listing and implementation. All right. Now, cluster sampling is where you pick your samples geographically. All right. Now, for instance, if you want to research on probably the impact of e-learning, if after the COVID-19, you want to do a research on the impact of e-learning on on students, the impact of e-learning on students after post COVID-19 when people have resumed to school. Now, you may want to do a random sample, but instead of doing that random sample basically from a source list, you come to ZTech University, which is your sampling unit. You already have a source list of the number of students, okay? The number, okay, because of course any sample there needs to be a source list, okay? Then from that source list, instead of using that source list to go around picking students, you basically do this. You go to the library, you pick 2 students. You go to the restaurant area, you pick 2 students. You just ask them, okay? Of course, you have to ask them, right? So that they can agree to, to responding to your questions, right? You go to, where else? You go to geographical places, okay? You go to the staff room. You can pick 2 teachers, all right? So because you want to get views on how students were impacted by e-learning, you get 2 teachers from the staff room. You go to the management offices. You pick at least, probably 1 manager can be enough. You choose one who can agree to probably answer your questions at a particular date and time. And then you also go to, where else? Where else can you normally find students? You go to a particular class, all right? You go to a particular class, you pick students. What you've basically done a cluster, a random cluster sampling, Clusters are basically divided into, clusters are geographical units, all right? Geographical units. Are we together? Geographical units. But for you to pick them from those particular geographical units, you pick them randomly. Okay, so that is cluster sampling. But it has its disadvantages because it may not give you a good representation of the group you're researching on, and also the students that you may pick. For instance, in this case scenario of picking students and other people to explain to you the impact of e-learning on students. You might pick 2 people from the library who are never even active in the e-learning program. They were not even active in the e-learning program. So what you've done there, you have had for yourself particular members of the sample that will not be in a position to give you reliable data. Okay? So you just pick randomly, or you go to the class, you just pick 2 people that are idling there that you think, these ones are free, they can actually answer my questions, right? Probably they were not even active in e-learning, right? You've just picked, they are not even active in e-learning, right? So it may not, it's one of the biggest disadvantage, because you may pick members of a sample that may not give you reliable data concerning the subject you are researching on, because it doesn't follow any criteria. It is anything goes. Everyone has a chance of being picked, of course, because it's a probability sampling. Everybody has a chance of being picked, but you've not used any criteria. You've not grouped into strata. You've not done systematic, where you can actually choose number of students in a particular order. Yeah, systematic, it doesn't even also have to be a number. It can be a letter. Like, if you've grouped the names into letters, you can say, I'm going to pick one from B. So you go to a city department, you pick a student that begins with B. You pick another student from hospital that begins with B, right? But in cluster, it's just anything goes. You go to a geographical place, you pick one. Another, you pick 1 or 2, depending on the number. And then, then now we have non-probability sampling. Non-probability sampling is where the population may not be well defined. Okay, the population may not be well defined, and in other situations there may not be great interest in drawing inferences from the sample to the population. Now, non-probability is where the particular group that you're researching on and that you want to pick a sample from, that particular group or population, that population cannot be well defined because it is broad. Okay, it cannot be it can be a finite universe, but it is a broad kind of universe. It cannot be well defined. And or also, to get it is the opposite of probability sampling, where in probability sampling, every member of that population had an equal chance of being selected. But in non-probability, there are no equal chances of being selected. It depends on particular criteria. You making it to the sample list, or a member of the population being chosen to be part of the sample, has to meet a particular criteria. Okay, otherwise they cannot be chosen. All right, so let's now see what are some of those methods of non-probability sampling? So remember, probability, everyone in the group has a chance, equal chance of being selected. All right. But in non-probability, there is no equal chance. You will only make it to, the researcher will only consider having groups from the sample that meet a certain criteria. Okay. So let's look at them. They are: number one, purposive sampling, convenience sampling, and quarter sampling. Okay. Those are the three methods of non-probability sampling: purposive, convenience, and quarter. Let's begin with purposive. Let's begin with purposive. What is purposive sampling? Purposive sampling, the researcher chooses the sample based on who he or she thinks would be appropriate for the study. The main objective of purposive sampling is to arrive at a sample that can adequately answer the research objectives. The selection of a purposive sample is often accomplished by applying expert knowledge of the target population to select in a non-random manner a sample that represents a cross-section of the population. Now, purposive or judgment sampling is basically where you basically pick a group of the population to form your sample, and that group that you pick must adequately answer the research objectives, meaning that you have to have a particular, they have to meet a certain criteria. And so you can, for instance, if you want to study, if you want to study, let's see, if you want to study, we were talking about political analysis, okay? Political analysis. Just a minute. You want to study political things, and there are very many people that have views on political issues. But for you to get a representation of what is happening in the political scene, then you have to pick political analysts. Now, you're going to actually pick people that are experts in that area. Are we together? People that are experts in that area. And why? Because by picking people that are experts in that area, you will arrive at a sample. Those experts are your sample that can adequately answer the research objective. So if you are researching on things that happen in the political scene, then you will pick political experts, and those political experts are going to actually do what? Political analysts who are experts to give you answers to your questions. So that is what you call purposive or judgmental, all right? In other words, the sample has to meet a particular criteria, okay? And then convenience sampling. Convenience sampling, this is unique. Convenience sampling is where you basically go out there, like what normally journalists do when they want to ask people questions out there in the streets. They basically pick people, just people that they meet in the streets, and ask them some questions. I think you normally see those things happening when they are preparing some reports, or they are preparing some program where people answer questions related to particular subjects, right? So you normally see them just go to a random person in the streets. So that is what is called convenience, okay? It is also called opportunity or accidental or haphazard sampling, where you will interview, or you will research, you will pick a sample from any person in the group, all right? From any person in the group. That one is called convenience. Whoever you find, all right? Whoever, okay? Whoever you find. But it is not geographically based. So do not confuse it with cluster. With cluster, everyone has a chance of being selected. So if you go to the library, everyone in the library has a chance of being selected. But in convenience, not everyone has a chance of being selected, because people are moving in a street, right? So Convenience is where the researcher using such a sample, you know, it is a type of non-probability which involves a sample being drawn from that part of the population which is close to hand. Close to hand. Whatever is close to you, you pick it. Okay? Whoever is close to you, you pick them. All right? That is convenience. Okay? Convenience sampling. All right? Uh-huh. Then I want you to research what quarter sampling is. I want you to research what quarter sampling is for your knowledge. And that one will be asked, all right? That one will be asked in an exam scenario, what quarter sampling is. So I want you to research on that. And what quarter sampling is, a type of a non-probability sampling criteria. Also, the other thing I want you to do is to study the advantages and disadvantages of each of those sampling methods. Okay, so that brings us to the end of sampling procedures or sampling techniques or sampling designs. So from the next class, we are going to now finish up with the other areas of sampling, and then we do data collection. Okay, so that brings us to the end of our class today. Have a good time, and please do those things that I have given you, that work that I've given you, to check what is quarter sampling, and also study the advantages and disadvantages of the different sampling methods that we have discussed. So that brings us to the end of our class today. Anyone with a question? Anyone with a question? Anyone with a question? Let me see. There's a question here. Yes, I will give cut 2. Cut 2, I will administer cut 2 next week. I will administer cut 2 next week. All right. There has been a problem with the portal. Most of you are not able to access the portal. Some can, but of course I will administer the cut 2 next week, and I will inform you in the group when I do. All right. So that is it for our class today. If there is no question, then I will end the class at that point. Have yourself a good time and study whatever. Remind yourself. I hope that you've also been writing some notes and trying to interpret whatever I've been teaching for your understanding. These notes are also going to be in the portal, also for your reading. Have a wonderful time, all of you, and let's meet in the next class.